Swayam Prabha. Digital India. Educated India.
Let us start this lecture with the thought process. Water is the prime mover of life in this beautiful earth. So, in the last lecture we are discussing about the irrigation system. Let us now look at another irrigation system which is known as interconnected tank irrigation systems. A figure I have shown here, in which if you look at, these are various big tanks and these tanks are connected with the smaller tanks or medium sized tanks, and then this medium sized tank is connected to a smaller one. People have found out something 1500 tanks around a seasonal river Palar that originates in Kolar district of Karnataka. In this river, the water flows predominantly east into the Bay of Bengal between Chennai and Pondicherry. And similar systems were also found in the Kaveri delta, what I was told. And if you look at, there is some data I would like to mention here, that something 11 large tanks, which is more than the 1 million meter cube, can hold around 60% of the total water storage, while remaining 187 tanks can hold only 40%. And these tanks, if you look at, the generally in each year the smaller tanks are get filled up, but whereas the larger tanks, when there is a flood or a very big spate of water in the river, then this will be bigger tanks will be filled up, and these are all connected. And as a result, you can have water storage in all these tanks, such that in semi arid regions like this, where unreliable rainfall conditions prevails, then we can utilize these water tank systems, optimize the what we call water usage and other things, so that you can get the crop. As a result, the food security will be ensured. But problem with this kind of tanks is that there will be silting as well, and those needs a regular maintenance. So, if you look at, this is quite sustainable system, and around that water is already there and you can have crops, right. It is not that it is located, it will be going for kilometers wise, so that in between you are having a space and where you can have your crops. So, sustainability appears intrinsic to the traditional Indian method. Nowadays the way we talk about sustainability, but it is sustainability is a part of the design in ancient India. So, that is very important thing what we need to, unfortunately these are not being maintained, and then these are all dilapidated condition, and we need to revive this if really we want to have a passive irrigation system. These are not active irrigation, these are passive irrigation system, interconnected tank irrigation system. In other words, interconnected tank irrigation system is the passive one, unlike the your dam and then sluice gates where it is active. Let us now look at another hydraulic engineering system which was there around 100 BC, and in Singha Verapura in Allahabad district of UP, and this work was excavated by B.V. Lal. And if you look at, this is the Ganga water, right, this water is flowing in Ganga, and there is a channel which is coming from the Ganga during the flood, particularly the water will be flowing through this canal, and which is around 11 meter wide and 5 meter deep. And during that flood time, what will happen, the water will come over here, there is a tank which is basically silting tanks, which will such that the silt will be settled down in this place, and then from that the water without silts will be coming to the second tank, which is having a brick lined, right, and this first tank, the silting tank, is having no bricks. And as I told earlier, that from the silt tank, the first tank, little clean water was directed to the second tank lined with brick, and then water is fed to the third tank, which is again with having step inlets. If you look at, these are the step inlets will be there, and again the water will come over here, and there will be also a fourth tank. It is of course a circular in shape, right. These are all rectangular in shape, but this is a circular shape. It had an elaborate staircase with elaborate waste weirs kind of things will be there, and consists of 7 spill channels, which are not shown here, like one channel is here, looks to be, there might be 7 spill channels. A crest, a final exit, this is the exit here, if you look at, this is the exit, excess water back into the river Ganga. So, if you look at during the flood, what will happen, you will take this, collect the silts around, and when the flood is not there, you can clean these silts and take these silts to the field and utilize it as a manure. And again the water can be recharging these areas, the area by the side of this river Ganga, and of course that will be designed properly, so that your recharging of water will be going on, and then crop you can get very easily. That means it will not flood the areas, it will be utilized, again it will go back to the Ganga. So, this is a beautiful system, hydraulic engineering system, which can be even utilized in modern time, right. Of course, more research is to be carried out how to do that and what are the things, but it is not being used in modern time. Let us look at this another dam, which is Surajkund and Anandpur dam. This is in Haryana, which is having a kind of a water will be coming over here and stored and silted. I mean, all silt will be removed from this place, and then after that of course it will be steps, it will go up, and this is the downstream view of the dam which is there. And Surajkund lies about 3 kilometers southeast of Toghlabad in district of Gurgaon. The reservoir is believed to have been constructed in the 10th century by King Surajpal of Tomar dynasty around 1000 AD. And let me tell you that today the dam is being protected by the ASI, but unfortunately a lot of things are being taken over the land, catchment area and other places by the local people. And this dam is an impressive edifice of 50 meter wide and 7 meter high, built from the accurately hewn quartzite blocks. These are the quartzite blocks. And of course, some work is being done by the IIT Delhi, Dr. Biravalli, who has done some work, and maybe some other people might have. I had a talk with him, and then who told that is a beautiful system. In this dam, what was happening, there was during the rainy season, the water will be flowing from the, let us say, upstream to the downstream. In the spring season, there is another under springs which were there, that will be going from the left to the right side of the dam. And there is a sluice system, sluice gate systems, which these are the gallery entry into the dam, where there will be sluice systems, and this steps into gallery inside dam, and this is the sluice outlet from this river, right. There is a sluice outlet in such a way that what will happen, like in the rainy season, the water will be flowing from this side to that side, and the other season, or the where it will be dry, there is a spring which is coming. That means water sluice system says that water will be coming from this side to that side. So, both the crops they can do in the different, both the sides. So, that is the beauty of these systems, which according to Dr. Biravalli of IIT Delhi, who was trying to investigate this and concluded this way. So, if that is the case, then it is very interesting structure which was built by our ancestors. We need to be relooked at from the engineering point of view. Let us look at the inundation channel of Bengal floodplains. This is your river bed through which water is flowing. This is one embankment, and there is another embankment on the other side with a cut in it, and there is a channel which will be during the flood time, this channel will be coming to the field, and these are the field which will be there. As a result, what will happen, the coarse sand will be here, and river during the flood, the fishing and the fine silts will be passing through this channel, and it will be the whole field will be inundated during the flood. That means, it will be supplying these silts which are having nutritional values, to the field where the crop can be made. According to Sir William Wilcox, a British irrigation expert, flood water enters the field through the inundation channel. These are the channels, right? And the water brings in rich silt and fish, and the fish fed on the mosquito larva and help the check malaria in this region. That was the interpretation what is being made. And it was prevalent just before 300 years back and got destroyed during British rule, and also there was a war, Afghan and then Maratha war, and during that time also this system was not maintained properly. As a result, this is being not in use, and of course, after independence and other thing, nobody really bother about to look at it, and this is very simple systems which were built earlier, and people are knowing where to locate these canals and how, what will be the distance, how much inundation required, lot of calculation, lot of data is required to design that one. And as I told, that canals were broad and shallow, carrying the crest water for river floods, rich or fine clay, free from coarse sands, right. As I told, the coarse sand will be here, right, will be, but whereas the fine sands and then the silts will be going. Canals were long and continuous, fairly parallel to each other and at the right distance from each other for the purpose of irrigations. Irrigation was performed by cuts in the bank of the canals which were closed when the flood was over. That means, if the there might be some sluice gates or maybe they will be cutting it whenever it is required, and do that in a regular pattern, so that the soil gets fertilized by the silts and also the water. The johars of Rajasthan, which is basically a rainwater storage tank used in the state of Rajasthan, which is an arid area. This is known as Khadin or the Dhora, designed by the Paliwal Brahmins of Jaisalmer, which is an indigenous check dams to harvest surface runoff water for agriculture based on the principle of harvesting rainwaters. If you look at, there is a rocky upland regions will be there, and the water will be flowing, and then there will be bandh, right. Bandh means basically it is a dam, and then water will be collected here and then it will be stored. For example, this place is a new one that where the dam is being built over in these regions, and if you look at, these are the catchment areas, the water will be stored here with this bandh, the khadin what we call. And of course, in the downstream this region you can have a shallow dug wells, because the water will be seepage percolate into it and it will be recharging these areas, this being a lower or the slope, and then you can utilize this for the irrigation purposes and even for using water for general day to day affairs. And generally long, like around 100 to 300 meter earthen embankment is built across the lower hill slopes lying below the gravelly uplands. For that you need to choose it properly, the place, and sluice and spillways allow excess water to drain off. There might be some sluice or the spillways, so that it won't affect this what you call bandh to be broken due to the water heads. So, let us look at another irrigation system in the western Himalaya, that is known as cool irrigation systems. Generally these are the glaciers which are there part of Himalayan, and it gets melted and diverted into the cool in these areas, and they will be diversion channel which will be making this one kind of things, and subsequently water gets collected into a tank, these are the tanks, right, and this water can be distributed for the irrigation purposes. This is the channels, and if you look at, this is the beautiful system which were there I think till 1980s in the Himalayan region, which was maintained by the local people, but unfortunately government interfered and then the whole system collapsed, and it was being maintained and they were charging the people for some revenue for supplying the water, and it was managed well. Let us look at another irrigation system. This is known as bamboo drip irrigation in Meghalaya region. They were using the hilly areas. They will be using the bamboo pipes. These are the bamboo pipes, right, which are used in those regions and used by tribal farmers of Kasi and Jantia hills. Bamboos divert water from perennial springs on the hilltops to the lower reaches by gravities, and it will be coming in a very slow manner. And what people have found out, something 18 to 20 liters of water entering bamboo pipe system per minute gets transported over several hundred meters, finally get reduced to 20 to 80 drops per minute at the site of plant. That might be lot of losses if you look at, these are the bamboo pipes, and then water will be transporting. And if you look at, they were managing to irrigate their land and cultivate also. If you look at this India geographical map, we are having various regions. To start with the Deccan Plateau arid region, the irrigation system will be different. This is the flood region, the Gangetic plains, right. This is a heavy rain regions in Assam, Meghalaya and other area. This is the mountain regions, and these are basically desert and arid region, Rajasthan or the run of Kutch extra. So, the same irrigation system cannot be utilized all the places, but unfortunately modern time people just put a dam and then go ahead and do that. So, there is a indigenous technology people had developed earlier according to their need and their understanding, and today it is not, those things, technologies are not being utilized unfortunately, and that has to be revived, so that we can have, depending on the need and local materials and technologies, people can use the traditional rainwater harvesting systems. Let us look at the reservoirs which were used for irrigation system in ancient India. So, this is the Bhimkund reservoir, which was basically built by Parma Raja Bhose around 1005 to 1055. A large dam cum reservoir, which around something 650 square kilometer, known as Bhimkund reservoir, by merging 365 rivulets and carefully erected various dams of moderate sizes. It had maximum depth of nearly 100 feet, these dams, like whatever they build. See, today people are talking about joining the rivers. It is the ancient time people have joined the rivulets, and these rivulets will be coming from these mountain regions, and they have joined, right. There is a lot of story about it, I am not going to talk about it, you can see that. They were having some knowledge about it, but today those knowledge are not really with us, and we need to relook at it. I would like to suggest that instead of joining the rivers which are very mighty or big, it is better to first get experience joining the rivulets, what our ancestors had done, and get some experience, and then you go and join those big rivers if the need arises. The dam wall is more than 1 kilometer long, now serve as a road connecting the Mendua village with the Bhojpur. And the upper lake, the Bada Talab, what we call, or the big pond, until March 2011 it was renamed Bhoj Tal. This is the Bhoj photograph or the statue they have installed here, and in the honor of great King Raja Bhoj who built it. And this is the topology of Bhimkund reservoir or the Bhoj Tal. This is the bigger lake which is there, and there is a smaller lake in this region, lower lake they call, this is called upper lake. And these are of course, if you look at Bhopal railway stations and Bhopal airports, all other things, this is a very big lakes. Still this lake is there. According to the W. Kincaid 1888, Bhimkund reservoir was the largest and most beautiful seat of fresh water in peninsular India. That is his claim. And it is the major source of drinking water for residents of city, serving around 40% of residents with nearly 1,40,000 meter cube of water per day as of few years back. If you look at, this is the Kamala Bandh, which is basically this is the big lake and this is a small lake kind of things. and top of the width of Kamala Bandh is around 120 meters and height of 18 meters. It carries even a heavy traffic today, hardly any repairs being carried out since then, and it is there. And this is the location of what we call Kamala Park. If you look at these regions, and this is the upper lake and this is the lower lake, and of course the Pulpukta is these regions, and this is the Kamala Park lower side lake, and which is not being maintained properly, and this water is stagnant, and also a lot of plants are being growing here which might be causing some pollution as well. One has to look at it. How was it built? The present study by K.G. Bass, a former advisor of Rajiv Gandhi Watershed Mission and director of Valmi, MP, that is Madhya Pradesh, confirmed that technically sound and economically viable site, the narrowest gauge, was chosen by engineer of 10th century. They have built this earthen bund, which is something 87 feet to 40 feet height, were constructed, one at the river Betwa and other to divert the river Kalisot at right angles to meet Betwa. Pitching of these earth filled bunds, which is not shown here, was done with the dressed stone blocks. These are the stone blocks. They were using the local red sandstones weighing around 1.5 to 2 tons. These blocks were laid on either side of the bund, on one on the other, without mortar, but fitting so truly as to be the watertight. This is a very important technology one can think of. Whether is it possible? Today I am thinking, how they are making the stone that they will be watertight, right? And is it we can repeat even with modern technology? What technology they were using? And also very important thing, they were using the local materials at that time. Wherever they will go, they will find out the local materials. And use of durable weather resistance construction material has survived for more than 1000 years, and the height of the bund was decided with such perfection that can withstand excessive flood during its lifetime. Of course, one has to look at what kind of technology, what kind of judgment they were having, what kind of design they were having. We need to do research on this, and unbreached dam wall even after witnessing weathering impact for more than 1000 still in good condition. That is of course I have taken from this K.G.'s Bass report and these statements. These big stones were there. This is the typical section of machinery work in Kamala Park in Bhopal, and this is of course still water, and this is the large stones are being used, and after that it is a dry ashlar, and this is a ashlar in lime. This reduces its width, and then of course you use ashlar coping kind of thing, smaller one. That they were also managing the silt deposition, because the silt deposition primarily depends on the relation between the inflow in the reservoir and outflow from the reservoir. In the upper lake, the ratio of reservoir area to catchment area was kept around 1.61 to 100 only. See what will happen if it is 100, the velocity will be reduced. If the velocity will be reduced, the silt will be deposited there before it is being transported downstream. And whenever it will be dry, then you use this silt, and then for the crop production, I think. This ratio allowed maximum silt deposition 3 meters in 1000 years, negligible small as compared to modern dam, which ensured the pollution free water bodies. That means what it indicates, that engineers of ancient India knew the construction of perennial sustainable water bodies with built in provision of silt removal at no cost, unlike the modern systems where silt has to be removed and then at a very larger cost, and it is causing a lot of problems to the most of the modern dams built by in modern India. Let us look at certain data about Biranam reservoir, which was built around 1000 AD. This was built by Rajaditya Cholas around 907 to 955 AD. Is around something 60 kilometer long dam with mean width of 4.8 kilometer in northern Tamil Nadu, and this reservoir gets water from Kolidam by a Bedavaru river. that I had talked about Colidam basically in the river Kaveri rivers as a part of systems, and its circumference of the tank is around 40 kilometer when it was full with water. This renovated lake located 235 kilometer from Chennai is one of the water reservoirs from where water is planned to be supplied to Chennai in 2004, because this is a big water bodies and then it can be utilized. Always the Chennai was having even today is having problem of water, but this project was unsuccessful as it got dried up, and subsequent digging of 45 deep bore wells around the area could able to provide water between something 50 to 100 MLD. MLD means million liters daily. That means whatever we had built, if we could maintain well, it can solve the problems of our water even in modern time. Surplus water of famous Kolanam dam, ruin condition, that is today, by the Chola Rajendra in around 1012 to 14 AD at Gangaikonda and Solapuram was used supply its water to the Viranam reservoir through a canal. That means, if you look at it, is a interconnected tanks were built in ancient India around that places. And very interesting things I must tell you, that the certain rules which were mentioned in the Arthashastra was also followed in south, that is, water of the lower tank excavated later on shall not irrigate the field already irrigated from the higher tank, and natural flow of water from higher tank to the lower tank shall not be stopped unless the lower tank has ceased to be useful for 3 consecutive years. So, these are the rules can be applied today also. So, that lot of dispute can be solved, because if you follow certain rules which are there earlier in the psychic of the mind of the people, then naturally it will be better for this. And with this I will stop over and we will see some more reservoirs in ancient India which are still being used and also can be revived without really much technology this thing, but however we need to study and improvise the methods of reviving them in a natural way than the artificial way being done for the making money. Thank you very much.